So here in this example, we have an exponential function that we're going to try and sketch. So the first thing I hope you notice is this -3 part. Right? The -3 is our vertical shift. So we're going to move our exponential function down 3 units on our y-axis. So 1, 2, 3. This is where our horizontal asymptote is going to go. Okay, we always have a horizontal asymptote at our vertical shift mark. In this case, 3 units down. Okay, and then we'll notice we have a negative in our exponent. Okay, a negative in the exponent can become a positive if we make our number into a fraction. Okay, so we're going to end up graphing what looks like 1/2 of x minus 3. So this is going to be a y-axis reflection and make this growth function into a decay function. Okay, so we're going to flip everything from the right side to the left side, which doesn't change your y-intercept. So we still have a y-intercept 1 unit above the horizontal asymptote. And since it's an exponential decay function, we know that as we have positive values of x, you're going to have 1/2 of that in the value of y. So it's going to approach your horizontal asymptote on the right side as x goes to infinity. And on the left side, we're going to experience the exponential growth in a negative direction. Okay, so here are some of those other points that make this into an exponential decay function that would match up like that. Okay, and do your best to make it look like some nice exponential decay. So we can answer some questions about this, like what is the horizontal asymptote? Well, since we moved it down 3 units, we have a y equals -3 equation of your horizontal asymptote. Remember, asymptotes are always equations of lines. Okay, we can also talk about the range of this function. Okay, and since it was moved 3 units down, -3 is going to be the smallest potential value, where infinity is going to be the largest. So even though it's decay, we still have a lower bound of -3, and that's once again where your horizontal asymptote is. And the domain of all exponentials is all reals. There's nothing that we can't plug into the power. Okay, and because this is an exponential decay function, the y values are always decreasing. Okay, let's come over here and look at another example. Here we have 2 to the negative of x minus 4. Okay, and I'm always going to tell you to try and rewrite this so that there's only, so that it has parentheses. If your x is negative, you need to have parentheses in your problem. So if we pull a negative out of this function of the -2x minus 4, then it becomes x plus 4 in parentheses. Okay, so hopefully you do this every single time you have a negative x. Okay, but only when you have a negative x. If x is positive, then leave it alone. Because this tells me that I'm going to shift my graph 4 units to the left, because parentheses always lie. So our graph is going to be moved 4 units to the left, and it's going to be a y-axis reflection. So I could rewrite this as 1/2 to the x plus 4 power. Okay, and that would give me the same thing as if I had 2 to the negative x minus 4 power. Okay, so because this has been moved left or right, I don't have to worry about my horizontal asymptote. It's going to still be going through my y-axis. Okay, so there are my axes. I have a horizontal asymptote through x equals 0 here. Or rather, y equals 0 is my horizontal asymptote. Okay, and when I move my graph 4 units to the left, I am basically moving my y-intercept 4 units to the left. So what used to be 0, 1 is now at -4, 1. Okay, that's probably the most important part about your exponential graph, is that potential y-intercept. So from here to the right, we're going to go half as much because we are decaying by 1/2. So the graph gets closer to my horizontal asymptote as x's go to infinity. And on the left side, as they become more negative, I'm going to have growth to the left. Okay, so this is kind of what all exponential decay functions look like. They are very positive on the left side of your graph, and they are very zero on the right side of your graph, or trying to approach your horizontal asymptote.